Compare with Soyuz, Crew Dragon is lavish. However, Dragon Boeing Starliner, SpaceX's Starship, or the in 50 years is its 9 rocket is to land on the ground. Launch escape system. Compare with Soyuz, Crew Dragon is lavish. However, the reason why Soyuz can serve for more than 50 years is its time-tested maturity and durability. The Soyuz has carried out more than 140 missions, over 50 years, has lost for crew members. None to launch failure. The overall casualty rate is lower than that of the space shuttle. Part of the reason is due to its landing escape system, which gives the crews 3 chances to escape from a failed rocket. The first chance, jettison-able emergency escape head section, or escape tower. The primary abort system for use early in the flight is the escape tower, which is a single solid rocket booster with several nozzles to control attitude. Placed on top of the capsule, when the rocket fails on the ground or at a lower altitude and is about to explode, the rower can quickly ignite and take the astronaut's descent capsule to escape from the dangerous area, and then open the parachute to return to the ground. On September 26, 1983, when the Soyuz T-10-1 was launched, the rocket launch pad exploded, and the escape tower with the return module quickly flew to an altitude of 1.4 kilometers and escaped from the scene. This is, to date, the only successful manned pad abort. However, Soyuz is the one who uses this escape tower the most but not the first. The idea of using a rocket to remove the capsule from a space vehicle was developed by a NASA engineer Maxime Faget in 1958. The system was first used on a test of the American Project Mercury capsule in March 1959. Historically, it was used on American Mercury and Apollo spacecraft, and for the upcoming Orion capsule, it will also keep the escape tower. The second chance, the solid rocket jettison motors on the capsule fairing. Its principle is similar to the escape tower, but the tower can only be used on the ground or at a lower height. When the spacecraft reaches a certain height, that is, 120 seconds after launch, the tower has been jettisoned. Then, the 4 rocket jettison motors installed in the fairing will provide the spacecraft with a second chance of escape. On October 11, 2018, the Soyuz FG rocket experienced an anomaly during staging, when one of the boosters hit the core stage and damaged the second stage 2 minutes after taking off.
Lo servimos directo de la freidora porque no hay otra manera, al menos para nosotros.
By that moment, it had reached the height of 50 kilometers. The ESC tower had just been ejected and the solid rocket jettison motors on the capsule fairing started in time, dragging the descent module away from the rocket. The spacecraft carrying the 2 crew members returning to Earth in a ballistic trajectory, during which the crew experienced about 6 to 7 times Earth's gravity followed by a successful landing. Both crew members were recovered in good health. The third chance, the engine on the propulsion module, was originally designed for altitude maintenance, but when the crew's lives are at stake, the engine can provide the astronauts with the last chance to get rid of the rocket. On April 5, 1975, 295 seconds after the launch, at the altitude of 150 kilometers, where the craft already exceeded the Kármán line altitude of 100 kilometers, and therefore reached a suborbital spaceflight, the rocket engine separation failure occurred. The spacecraft completely lost control and fell into violent rotation. The escape tower was long gone. By this point, the abort had to be performed with the Soyuz's engines and the propulsion module. This separated the spacecraft from the third stage booster, and then separated the orbital and propulsion modules from the re-entry capsule. Despite very high overloading, the capsule successfully landed after a flight of only 21 minutes. The crew, who initially feared they had landed in China, were successfully recovered. As a derivative of the Soyuz, China's Shenzhou completely inherited the launch escape system of Soyuz. From the first launch in 1999 up to date, the Shenzhou has launched 12 missions. Fortunately, no one ever failed, and the launch abort system was never deployed on an actual spaceflight. Due to the recently launched Chinese space station Tiangong, the following 2 years will be action-packed for China's space program. Shenzhou will send crews to orbit at a rate of twice a year. Wish their trip safe and sound. Finally, let's take a look at the launch abort system of the Crew Dragon. Compare with the older pull method. What Crew Dragon applied is a newer push method. The Crew Dragon abort system is built around 8 liquid-fueled 3D printed Super Draco rocket engines mounted in pairs around the exterior of the capsule, each one capable of generating 16,000 pounds of thrust. A system of sensors throughout the Falcon 9 feeds telemetry to the ship's flight computer, which constantly monitors the performance of critical components. Should a major malfunction be detected, the computer is programmed to instantly fire the Super Dracos, blasting the capsule away from the Falcon 9. It can also be used for the ground-based landing. The abort system also can be triggered manually, using a large pull and twist handle mounted between the astronauts. Compare with Soyuz and Shenzou. The abort Crew Dragons is an integrated escape system. It has the advantage of being applicable at any time and at any point in the flight, so-called as full envelope abort system. No separation of the tower means less separation failure, and the escape system can be reused, more cost-efficient. However, since the Crew Dragon used splashdown landing, the launch abort system probably will be less reusable. In the next few years, Crew Dragons will undertake the most intensive missions. There are contracts from NASA, Axiom Space, or even all civilian mission inspiration for. Space is more accessible than ever. The dream day when ordinary people go to space seems to be getting closer and closer. Hopefully none of the launch escape system will be needed. Docking system.